Hey guys, good morning, all of you. Can you hear me? Hello.
Yeah, hi, I can hear you.
Yes, I can
Yes,
hear
sir.
you.
Yes, sir.
Thanks, Sunny.
Hello, good morning.
Hey, good morning, Sunny. Good morning. Let's start. So, guys, quick summary. What we have done in the few days, we have done what is routing. Just keep just a small recap, right? What happened? Why my tab is on? What is routing? What is router? How to configure? IP address on router interface, and how does router maintain routing table, and what is the use of IP routing command, right? And also we have seen how to configure static route, right? And we have seen the all the three ways we two ways we have seen. I think so. If I'm not wrong, just let me know. Okay, we have seen this way: IP route, destination network, and we have then subnet mask information, and then we have a next hop, right? And then we have a IP route, destination network, subnet mask information, and then we have a next hop, not next hop, exit interface. And also we have seen the concept of AD value, right? What is AD, right? We have seen the concept of AD and longest prefix match rule. The longest prefix, how does router decide from which interface, not from which interface, which route, which path I need to select forward. Awesome, right? And this command we have seen the IP route destination network. This command, in this case, uh, the router will generate, right, app request for only for next hop. So if you have 1000 destination network, you will maintain, router will maintain only R entry in cache, in R cache. Cache is like a small memory, right? In this case, what happened? Good morning, Hussein. Hey guys, tell me, am I done with this command? IP route destination network submit mask, then exit interface, then next hop. Yep, I think so. I'm done.
Yes, sir, you have done it.
Yeah, I'm done. No? Like
Yes.
how to avoid the recursive lookup. Yes, perfect. So we have also done with the this command. IP route destination network submit mask information, and we can call it exit interface, and then we have a what we call next hop. Right, recursive lookup. What is recursive lookup? More than one time lookup to a single route known as. It's not. It's a bad guy, right? not the welcome to you. All good. So we have done with this concept, right? Now, if you have any questions from this, you can ask me. And one more thing, AD is local to the router, right? It's a 8-bit number, or what we call. You can define from 1 to, actually you can define from 0 to 25, but 1 and 0, sorry, 0 is reserved. So you cannot use 0, right? But you can define the 180 value, what can you have the 2, 3, 4, 5, 6, you can define from this. 255 is unknown, right? So if any route that has a AD value 254, router will inject that information in the routing table, right? The route, if any route that has a AD value 255, router will never inject that information in routing table. Okay, but in running config, that information will be there. Vistas of memory and vistas of CPU. Also, we have seen another one more command was there in the static route. Destination route running submit mask next hop, or we can actually call this exit interface as well as, and then use the permanent keyword. Let me know if you have any questions from this line. Just 1 minute. I hope this all these things is clear to all of you guys. If you have any questions from this, like I'm welcome to all your questions. Otherwise, we'll move to the next one.
Sir, what is that last command?
Sorry,
Sir, what is that last command?
it's a permanent keyword. Permanent keyword is something like that. No? If you remember that I told you, like if the next hop is not reachable, right, the router will remove that information from the routing table. So in that case, what happened? The router is just increasing the CPU. Take example, if the interface get bouncing, right? Bouncing means or flapping. Okay. So in that case, what happened? The router CPU will be hit, right? So to avoid this thing, we can use a permanent keyword. In the permanent keyword, what happened? If your next hop is not available, still the router will maintain this information in the routing table.
Okay.
Hi Arvas, the session is being recorded by me, so don't worry, I will share the recording. Is it the call floating study? No, Biddy, it's not a call floating study. I'm coming to this topic, floating study. Okay, now take example. This is my router number 1. Okay, and this is the ISP. Okay, so this is my company network, right? One of the company we have. So in the company, whatever the user are sitting over there, right? Whatever the user are sitting over there, all this guy is trying to access the internet, right? All this person is trying to access the internet, or we can say the any network that is behind the ISP. So we can call this guy the 2.0.0.0, right? Just single network, right now. And so what happened? This is my router number one, and this is my this is my router number one. This is my ISP. So I have to take a one connection, right? So I will take a one connection between this guy to this guy, right? And this interface is 0/0, and I can call this guy as IP address will be, it's 12.1, and this guy has the subnet I'm going to use over there /24, and this guy will be 12.2, and this interface again we have a 0/0. Perfect, right? So in the R1 routing table, what information we have? We have a 12.0 that is connected by the 0/0 interface. At the same time, we put the one static route, that's 0.0.0.0, that has AD value 1, metric will be 0, and next hop will be 12.2. This information we have in the R1 routing table. Okay. So right now, whatever the user are present over there behind the router one, or we can say in the LAN network, this guy is able to reach to the this network, right? Is the ping 2.2.2.2.2.2, and my all traffic, right, will go via this physical medium. My return traffic is coming via this physical medium. So there is no issue, right? All this guy can communicate with the this particular person. But take example, this link, right? Or I'll let you know one more thing over there. This is my what we call, this is my 20 Mbps link, right? This is my 20 Mbps link. What happened if this link goes down? If this link goes down, can this user reach to this network? Of course not. Now, whatever the user are behind the R1, can they reach to this network 2.0.0? Of course not, never, because this path is not available now, right? This path is actually not available. See, the path is not available. How does this person can reach to this guy, right? Because of course we are using the technology that is what? Wired media. In the wired media, what happened? We must need to have the wire, and if the wire is not there, if the link goes down, do I have a reachability between this person to this person? No. So all my traffic, right? Whatever the user will send the traffic, all the traffic will drop on the R1 side. All the traffic will be drop on the router number one. So to avoid this problem, what happened? To avoid this problem, to avoid the single link failure, right? This is known as a single link failure. To avoid the single link failure, what we have introduced? We have introduced the backup path as well as. We can say that, okay, let me put the another link. Let me put the another link. And what about this link? Now this link has a, it's a 0/1 interface, and this is also 0/1, we can call it, right? And this guy has IP address will be 13.1, and this guy has a 13.2 IP address, right? And I'm going to use the subnet over there. It's a 13.0/24, right? And this guy is like what? It's a backup path, right? This is my primary link, right? This link is my primary, and this link is my secondary, right? For the secondary link, what happened? For the secondary link, we are giving the bandwidth of this person will be negative 5 Mbps, right? Now, try to understand this is my secondary link and this is my primary link, right? It's like a if you watch the Titanic movie, right? In the Titanic movie, what happened? We have a big ship over there, and on the big ship, right? We have some small lifeguard was there, right? Some lifeguard was there, right? And like some small ships was there. Sorry, lifeguard and some small ships. Backup one. So guys, if this guy is a backup one, what happened? So I need to define another static route from this path as well as. So if the primary is not available, I can send my traffic from the backup one, right? It's good now. But you know what's problem is happening? At the same time, right? At the same time, both information is present in my routing table. At the same time, both information 2.0 from the 2.2 and 2.0 from the 3.2. What's problem is happening over there, guys? See, if I'm going to talk according to the scenario, right? Take example, what my scenario is happening. If all this person is going to send the data traffic, is all this person, listen to me guys, it's very, very important. If all this person is going to send the data traffic over there, right? It's good. I'm able to do this router one is going to do the load balancing. I can share my some traffic from this guy, and I can share the some traffic from this guy, right? I can utilize both the link. I can utilize both link. According to the data traffic, right? This person, this guy is very, very good because maximum all my data traffic, right? Normally what happens, all my data traffic, like if you want to send some file, if you're downloading something, anything, normally maximum time it's going to use the TCP, right? So what happened if some delay is happening from this side? Of course, this is the 20 Mbps link, this is the faster, right? And this is the slower over there. So somehow if any delay is happening in the data traffic, and you know, due to the delay, some packet loss is happening. Take example. We have a reliability, right? We have a reliability because TCP is what? It's a retransmit the packet. So in this case, this is awesome, right? I can utilize both the link. I can put the route. This information present in my routing table, both the path, right? If the person is a ping 2.2.2.2, I can send my traffic to a 12.2 and I can send my traffic to a 13.2. I'm not telling you it's bad, it's a good design, right? But take example. If the traffic is voice or video, UDP based traffic. Now tell me, do we have a reliability over there? In this case, load balancing is not a good solution. Load balancing is bad. In this case, what I want, all my traffic will follow the 20 Mbps link right? Not via the 5 Mbps, because UDP is like, it's a faster and does not provide any reliability or not the retransmit mechanism. So if the packet loss is happening, packet loss. For example, I'm sending you some information like, hey, how are you, man? And you're saying, hey, how are you? Where's the man now? I'm sending some like, the some account, like I'm telling the account number on a phone call, on a video conferencing call. And what happened? You missed something, or maybe the another person has heard, like instead of the 2, he heard the 1. What happened? He will make a wrong transaction. Why? Of course, buddy, right? Because this is not like a reliable. So in that case, what happened? I always want to use the 20 Mbps link, not the 5 Mbps link. So if the 20 is not available, I can transmit my packet from the 5. But if the 20 is available, I always transmit my packet from the this one, and 5 will be disappeared from the routing table. So all my traffic, according to the routing table, we just have a single information, not the this information. Load balancing means what? The name says load balancing means what? I can share my traffic, right, from both of the link and this link as well as sharing the load. That's the meaning of load balancing. Some packet will go via this direction, some packet will go via this direction, if the both link is present in the routing table. But sometimes load balancing is not a good solution, right? Because if you have a voice and video traffic, I cannot send my traffic from the 5 Mbps link, right? Because this is the slower as compared to this one. But sometimes load balancing is good. It's totally depend on the scenario, right? Now, what I want, if the 20 Mbps link is available, I always send my traffic from the 20 Mbps, not from the 5 Mbps. 5 Mbps will be disappeared from the routing table. But take example, if the primary goes down, the primary link, the secondary will be always available in your routing table, and now the primary will be disappeared from the routing table. Now all my traffic will go by the 13.2. Like if the big ship, right? If the big ship ship down in the sea, what happened? I can transfer the people in the, I can transfer the all the people in the small ships, and I can give to the lifeguard. I can give lifeguard to the people, right? So that they can save the life. Same thing is happening over there. If the primary is not available, I can push all the traffic through the secondary link, right? If the primary is not there. But if primary is there, right, secondary will be disappeared from the routing table. It's like that we are floating this 2.0 route with the 13.2 next hop. And this mechanism is known as a floating static route. What I'm going to do over there, guys, just because of the AD value, right, 1 1, just because of the AD value, both route is present in my routing table. I'm just going to change the AD value of this person, any AD value more than higher than 1. I will put the 2 over there. Don't use any AD value that is reserved by the some other routing protocol. For example, EIGRP 90, 170, OSPF 1110, RIP 120, BGP 220 and 200, EIGRP 75. Don't use this AD value for the floating static route. If you're going to use this AD value for the floating static route in future, or somehow if other company is going to use the same route and they have advertised the same route in the EIGRP, the loop will be happening, right? That's why it's never recommendation to use the any reserve AD value. Use any value that is not reserved, like 2 is not reserved for anyone. So now what happened? If I'm going to give the 82 2 over there, so what happened? As we know that a router always maintain what? Best path. So those route has a lower AD value, I will give the preference, right? So this will be not appear in the routing table if you already have a AD value 1 with the 2.0. So I always send my traffic from this link. But somehow, if the parameter is not available, take example, if the parameter is not there, somehow if the parameter is not there, what I'm going to do over there? Now, this will be appeared in the routing table automatically. You don't need to do anything. Automatically, this will be done. Again, if the parameter comes up, take example, automatically what happened? Secondary will be removed from the routing table. This mechanism is known as a floating static route. So if the primary is available, I always send my traffic from the primary. If the primary is not available, secondary comes in the picture. Again, if the primary get back, secondary goes down, or secondary will be disappeared from the routing table. Right? If the both link is from 20 MPS, then you can use the load balancing. There's no need to change the AD value, and there is no need of concept of floating a static route. PL means primary link, SL means secondary link. So IP interface brief. Perfect. We all have IP addressing on the router number 1. If you see the fast Ethernet 0/0, we have a 2.1, and 0/0 is 30.1. Awesome. On the router number 2 now, it must be have one loop back. Okay, they don't have any IP address. Let's configure it. All done. Good to go. So now on a R1, save this configuration. Did I forget something? Yeah, scalable. On a R1, I need to define a one static route towards this guy 2.0.0.0 and subnet mask 2.2 and IP to 2.0.0.0.0 subnet mask, and I need to define the 30.2 now. Do so IP route. If you see one thing over there, what happened? Both information is present in my routing table. That's not a good thing, right? And if you see, if I'm going to ping 2.2.2.2.2, 3.2.2.2.2, can you see I'm utilizing the both the link, right? Utilizing the both the link. Load balancing is doing right now. You load balancing is share the traffic, right? From both the link. What I want right now, both route is present in my routing table, right? I always want the packets to be go by the primary link, not from the secondary link, right? What I can call over there, IP to 2.0.0.0, 2.13.2 next stop, right? Both the link, man. Can you see 12.2 and 13.2, 12.2. What I going to do over there? If you put the question mark, we have a AD option for the route. I can define the AD for this particular route, right? From this side, 13.2 next stop. The AD will be anything from this range 1 to 255. I can put the 2 over there. Once I put the 2, what happened? This route will be disappeared from the routing table now. Can you see? Do we have a 2.0 associated with the 13.2 now? No. But in a running config, this should be available. It will, a router is not going to add this information in the routing table because router always maintain the best path. And how does router will decide the best path? Based on the lower AD value, right? Because they don't have a metric concept, right? A static route does not have metric concept. So it always give the preference to whom? Lower AD. So once I define the lower AD, what happened? My only one path is yellow. That is primary, right? The 12 or 2. So now if I'm going to make a trace route, can you see all my traffic will go by the 12 or 2, right? And somehow if the primary is not available, take example, somehow if the primary is not available, what happened? I'm removing the primary route, 12 or 0 is deleted now. And whatever the route that is associated with the 12 or 0 is also going to delete now, 12 or 2. I'm adding which route? That has a AD value 2. And now do show IP route, good to go now. And now all my traffic will go by a secondary. Because the primary is not available. This link is not available, right? So all my traffic will go by the secondary link. But take example, if the primary will be appeared, right? What happened? Secondary will be disappeared from the routing table now. Do we have a secondary route? No. And all my traffic will go by the primary. This mechanism is known as a floating static router. Questions? No? Good. So guys, one more thing that you have to write down right now. Okay, I will explain you this part when I'm coming to the dynamic routing protocols. in redistribution part. You cannot just write on this line right now. Okay. Zero. This line you have to write only. This person is important. Which one I need to explain, Gulabi? Can you put your masses in the, like, publicly, so that everyone can see your masses and they can also understand what I told you. This guy I will explain you in the dynamic routing protocols, not now, because you will not understand this part right now. Just need to make a point. Okay, I'll explain you this part in the dynamic routing. Which one? This one you're talking about? Which one you're talking about? Gulab? Tell me. Or top one and the bottom one? No, perfect. So that's why the yellow one I will explain you in the dynamic routing protocols when I'm going to teach you the dynamic, because this topic is almost 2 hours of the topic, right? I cannot teach you right now. You will not never understand right now. So just make a point. I will explain you in the dynamic routing protocol. And this is the point is a static route, because many times what happened when I'm giving the training, like I forget this part, right? So I'll just mention it right now, just write on. And when I'm teaching the dynamic routing protocol redistribution topic, this topic, let me know on the time. Guys, here I'm done with the static route. If you have any question from the static route, you can ask me. Question is now, why does, not why does, what are the disadvantages of a static route? And what are the advantages of a static route? Tell me. Config overload, overheat. We have to manually configure. Anything else? Can deploy, can't deploy in the large network. Time consuming. Error may occur, right? There are stable for only some topology. Okay, good. A very good exam, like advantage. It's advantage or disadvantage? It's advantage or disadvantage? The stable one. cannot reroute the traffic. Good one. See, almost everyone is correct, right? The about the disadvantage of the static route. Okay, you cannot define the policy. Like you don't have a the options to manipulate the path. Not good for the large network first we have mentioned over there. And what is the biggest disadvantage of this guy? I'll tell you, right? For the stable one of the guy who's put the like a stable one. What's the meaning of stable? Take example. This is the guy over there, right? Okay, this guy has a phone number 123, and this is the another guy. This guy has a phone number 456, right? So in this phone number, B associated with the 456, and they have a number of A associated with the 123. This is the A and this is the B. Take example, right now they are able to communicate to each other, right? Because they have a number. But what happened if the B is going to change the number? He said, now my number is what? Now, are they have any mechanism, right? Are they have any mechanism to inform to the A, hey, I have changed my number? No. According to the A phone book, what happened? B associated with the 456, but B had changed the number 789. So in the manual configuration, what happened, guys? Take example, if the router 1 is there and if the router number 2 is there, and behind the router number 2 we have server this is 2.2.2.2.2.2, and in the routing table of R1 we have a 2.0 information associated with the next of level 2, right? That is this guy. But take example, if this guy had changed this person, he said, okay, now my IP is 3.0.0.0.0.0. What happened? R1 will keep sending the packet to the 2.2.2, and all my traffic will drop on which side? R2, because they have changed the number. So do they have any mechanism to inform the router one, hey, I have changed my number? No. Static, not possible, because everything you are defining what? Manually. Everything you are defining manually. They don't have any mechanism. If someone has going to change the network, if someone has going to change the number, they don't know how to inform the other guy. Same thing is happening in this case, right? If this guy is going to change the number, how they will inform to the other person, hey, I've changed my number? No, it's not possible. Yeah, of course, 100% right. If something has changed, you have to manually define again. There's no info, there is no control plane packets. This is a very good example, right? If someone has changed the number, can I make a call to that guy? Take example, if I'm going to change my Zoom ID. Take example, if I'm going to change my Zoom ID manually. Will you able to connect? Will you able to reconnect the same class? No, if I'm not going to share with you. So that's why it's not a recommendation to use this one, right? Static route. In the big network, right? What is the advantage? Easy to configure. Security, right? Security in the sense of what? I only need to define the specific route. So in that case, what happened? No one can perform the attack in my network, right? If I'm not going to define the reverse route for the that direction, I cannot send my traffic. And a static route is more preferable route among all the dynamic routing protocol just because of 80. This guy has a lower AD value 1, and that is amazing as compared to the any other one. No need to further a very good engineer. A normal engineer can a CCNA guy can also deploy this static route. There's times like the cost saving, cost cutting we are doing over there, and this is only for the small network, not for the big one. If for every LAN network did we prefer a static route? Nobody a hurry. It's not like that. Okay, like it's totally depend on the scenario. Again, I'm repeating, right? If you have a very small network, you can do that. But if you have a large network, where you have a 10 to 15 routers over there, you always go for the dynamic routing because, and again, the static route does not require the much amount of CPU. So if somebody will ask you, hey, where should I prefer this style? It's totally depend on the scenario. And if you take example, I have a very big network. Take example, I have a very big network, but my memory and CPU is not much. Can I do the dynamic routing protocol over there? Of course not. You can't do that. Do the static. It's true, right? It's totally scenario based, right? On a server side, of course, on a server side, if you're going to define the nizam, what happened in that case? If the server is going to change the IP address, then someone is going to change the. Take example, Facebook server, right? Google.com. If someone is going to change the Facebook and Google, are you able to send the traffic again, again, again? No, you can't do that. You have to keep tracking. You have to keep tracking on the static route. But if you have a very small network, right, you can use the static route like a default route concept. We can use it, right, in the default route from the customer to the ISP side. We can define a default route a static way, right? Right. So these are the advantages, or these are the disadvantages of the static route. Clip. Now, so guys, I assume that you have an idea of the default route. I'm not explaining what is the default route. The very small topic. Define a 0 0 0 0 0. This is the less specific route. So if why I'm going to use the default route, so that why default route, so that we don't need to maintain huge amount of routing table. Right, that's why we are going to use the default. I'm not this already the CCNA, right? Nothing is like difference over there. So to avoid all this issue with the static route, what we have introduced, the concept of the dynamic routing protocol. In dynamic routing, we have a multiple types of routing. We have a we have a red protocol, we have a EIGRP, we have a OSPF, we have a EIGRP, we have a BGP, we have a ISS. This is not a part of your syllabus. It's coming in the CCI, and this is totally a legacy. We are going to discuss about this 3-1. Today I'll show you what is the meaning of dynamic routing, right? How the dynamic is going to work. Okay, what's the main difference between the static and dynamic? I'm not going to teach you any protocol right now. I'm just going to tell you what is dynamic actually. So guys, let's take example. What is IPSOS even those are the dynamic routing protocols. What is IPS? Those are the, yes, it's the dynamic routing protocols. What is IPS? I think IPSOS. I never heard that. Yeah, I never heard that. What is that? IPSOS protocol. Or we can just go this IPS is compressed is IPS women provide written job opening. What is IPS? It's a job something. IPSLA. SLA is a service level agreement. So what do we call? Nizam Fayaz, right? It's a service agreement. In that case, what happened? We can define the service to the next hop router. So if the service is not given by the complete service provider, we can read out the traffic, right, in the static route. That we are going to learn in the advanced port topic, right? How the IPSL is going to work. It's actually part of the the switching batch, but normally what happened, we were discussing in the the advanced chapter. Now let's understand how the dynamic is works, guys. How dynamic works. So we have router number one. Okay, we have router number two. I'm not teaching any dynamic routing protocol. I'm just explaining how the dynamic is working. Router three. Dual router one. This guy 12 or 2. This guy 23 or 2. This guy 23 or 3. This guy we have a 12 or 0 slash 24. This guy 23 or 0 slash 24. We have some loopback on R1. That is a LAN network of R1. This is a loopback on R3. That's a LAN network of R3. And this is the loopback of R2. That's a LAN network of R2. Every router, as we know, that maintains the routing table. So this is the routing table of R1. See, loopback one. See, 0 slash 0. This interface we are 0 slash 0. Right. The R2 routing table we have. Or the R3 routing table we have. Right now, try to understand. I'm just introducing, right, one dynamic routing protocol. My dynamic routing protocol is what? X protocol that has AD value 100. I'm just assuming myself, right? I'm just explaining you how the dynamic is going to be work, right? By default, all routing protocol are enable or disabled in the routing table. By default, all the routing protocol is disabled, man. You have to manually enable it. Now, take example, I have enabled the X routing protocol on this guy, okay? Because this is the routing protocol that's introduced by me. X I have enabled on this guy. X I have enabled on this guy. X I have enabled on this guy, right? After enabling the X, what happened, right? I'm not teaching you right now. If you have an idea of like neighborship address is good, so I'm not discussing about that part. I'm just discussing how dynamic works. So what happened? R1 is going to share this information to the R2. Hey R2, I have something for you. What he will tell you, I have something for you. And what something? This something. He's informing, hey, I have something, some route for you that is 1 or 0 or 0 or 0 or 0 and 2 or 0. What is the AD of connected now? Right? Once R2 will receive this information on this particular interface, what they will do? R2 said that, hey, I already have a 12 or 0 by a directly connected out. See, is directly connected, right? So what happened? I'm not going to install the 12 or 0 information because I already have a best path information. I will say that X 1 or 0 that has a 180 12 or 1. I'm loading this information on 0/0 interface. And I'll put the some metric value. Don't worry about the metric, what is metric about this part. I'll explain you what is metric concept. So this information I'm going to add in my routing table. X is the routing protocol, that's the identification 1 or 0 I'm getting. The AD value of this guy will be 100. Some metric, and I'm learning this information from the 12.1, and I'm learning this route on 0/0 interface. Why I'm not adding the 12 or 0? Because I already have a 12 or 0 in my routing table with the AD 0. And he's saying the AD is what? 100. So lower is always preferred, right? Same thing, R2 is now going to send the own information to the R1. Which information? 2.0, 12.0, and 23.0. R1 will say that, hey, I already have a 12.0 with the AD0 over there. I will prefer this guy, right? That has a 100 AD. Some metric will be there. I'm learning this route from the 12.2 on which interface 0/0. Same thing, X 100 metric, sorry, AD value. Some metric will be there. 12.2 and learning this information on which interface 0/0. So both exit interface and next stop will be added. Exactly, both information will be added in the routing in the dynamic routing protocol case. If I'm going to talk about the EIGRP, the RIP, and OSPF perspective, not the BGP one. This is this interface, and this is this guy 12.2. Same thing now. R2 is going to share the own information to the R3, right? Which information they will share all this information. Hey, buddy, I have something for you. That is 2.0, 1.0, 12.0, and 23.0. R3 will say that, hey, I already have a 23.0 with the better route connected AD. I'm not going to consider this guy 23.0, but I will prefer this one. X 100, the AD values of metric. Next stop will be 23.2. I'm learning this info from 0/0, X 12.0, right? And X. Yes, Hari, to prefer the lower AD value. Now R3 will share the own information to the R2. And in this case, what information I'm going to send? He will send, hey, I have something for 23.0 and 3.0.0. So R2 will say, hey, I already have a 23.0 with a better ID, that's a 0. I'm going to make this guy, right? 3.0 information. Once the R2 will add this information, what R2 will do? R2 is now going to share the own information to the R1, right? Hey R1, I have something for you. Which one? 3.0.0.0.0. And now R2 will add this information in the routing table. Hey, 3.0.0.0, that's coming by the R2. Right? And now all this router is going to extend the route, just enabling the protocol. Can you see that? Did I perform any kind of manual things over there? No, just enabling. And after that, all they are doing background. Take example. If this route goes down, right? Take example. If this one goes down, what happened? You know, R3 will inform to the R2. Hey R2, do one thing. Remove this route from the routing table, because now is also going to remove. R2 will receive it and remove this route from the routing table. And R2 will inform to the R1, hey R1, do one thing, remove this route from the routing table. And R1 will remove this route from the routing table. And instead of that, if they will, the network engineer is going to change the network, and instead of the 3.0, now they will put the 4.0.0.0.0. So what happened? This guy is going to add the 4.0.0 in the routing table, and they will inform to the R2, hey, add this information, the 4.0 in the routing table. And R2 will inform to the R1, hey, R1, add the 4.0 in the routing table. So now this guy will add the 4.0 in the routing table. So did I manually configure the 4.0 in the routing table? No. All this thing is happening. Doesn't matter if you have a 100 plus router. It does not matter if you have a 100 plus router. Everything is going to being added by the router. Every routing information is being added by the router. You don't need to do anything over there. If someone is going to change the network, inform the other person as well as, hey, someone has changed the network. If something goes down, inform the other person something goes down. If something comes up, inform the other person something comes up. This is how your dynamic routing protocols works, guys, as compared to the static one. And every dynamic protocol has a different logics. So take example, the R2, you know, the R2, if R3, take example, if R3 is going to be added one route, maybe 20.0, take example. So what happened? In some routing protocol, I'm not going to tell the name right now. I'm just telling you the difference. It's not like that every routing protocol is behave like a same, but the dynamic works like that. Here my agenda is what? I'm just explaining the terms of dynamic, not the dynamic routing protocol, how the dynamic is working. And depend on the routing, for example, if I'm going to talk about some protocol, if I'm going to advertise the 20.0, what happened? R3 will say the complete routing information to the R2. Complete routing information. If something is going to be added, right? So R3 will say the complete routing information, complete table, whatever the route they have. But in some routing protocol, they only say the 20.0.0, not the complete routing information. How much time will take, sir, for update? How much time it will take? That's depend on the routing protocol, guys. That I told you, guys. Every routing protocol has a different behavior. If I'm going to talk about the RIP, 30 seconds. EIGRP, 5 seconds. My again, I'm not explaining you any routing protocol. I'm just explaining you how the dynamic works, guys. So don't confuse with the dynamic routing, but I'm just explaining the term of dynamic. Guys, anyone have the questions? No? Perfect. So guys, see you tomorrow with the dynamic routing protocols. I'm just going to discuss about the tomorrow RIP classes, right? So yeah, now perfect. Good, thanks. So tomorrow we are going to start from the RIP, and I will conclude the IGRP as well as. I'm not going to tell you the detailed information on the RIP and IGRP. Yes, I'm going to tell you the thing that is not present anywhere, right? That's very, very important. I have already said that yesterday one RIP classes video, the driving, the 3 videos are there. Actually, the 5 videos are there. I don't know who has changed the, like who has deleted that video. I seriously don't know. So just follow that video. That's enough information about the RIP protocol. But yes, tomorrow is an important class for this one. I'm going to discuss the tomorrow this part, like how and what are the disadvantages of the RIP and IGRP and why we are not going to prepare this guy. And then to after the Wednesday, I'm going to start your EIGRP. So tomorrow is very, very important. Let's we'll get the idea what is the problem with the RIP and IGRP, and what is the meaning of complete routing information exchange. Could you please add me in the drive? Do one thing. Just ping me on this number. Oh, okay. And 1 minute.